Hello guys, this is Rakesh from Bodhee Prep, and in this video we'll be continuing what we did in the last video. We understood what are the factors and what are prime numbers, right? So we'll be extending the same logic. Today we'll be focusing primarily on SCF and LCM, right? So let's start the process. So from the previous session, what we understood is that how to find factors and what are factors and how factors and divisors are interrelated, right? Now, if I take the logic from the previous video and I take say two numbers, let's take very small numbers. Say I'm taking a number 4 and I'm taking another number 18, right? What I'll be doing is that I want to find the factors of both the numbers. Correct? Both are very, very small numbers. We know that prime factorization is also one way of finding the factors. And the other way is that because these are very small numbers, we can just by using simple logic, we can find all the factors. For example, for 4, we know that 1 is factor for all, right? Then 4 is divisible by 2, right? So 2 is another factor and 4 itself will be the factor. 3 is not divisible by 4 or 4 is not divisible by 3. That's why 3 is not the factor. So the largest factor would be 4 because no factor can be more than the number for which we are finding the factors, right? This is very, very obvious. Now for 18, the similar kind of thing which we can do is that 1 is the factor, 2 is the factor, 3 is also a factor, right? Because 18 comes in a table of 3. Similarly, 4 doesn't appear, right? So 4 is not the factor, 5 is not the factor, right? 6 is the factor, right? 18 into 3 is 6 because we can write 18 as 3 into 6, right? Similarly, the next number is 9 and the last number would be 18. So these are the respective factors of these two numbers 4 and 18. Now my objective is to find, is there anything common between the factors of these two numbers? So if I want to figure out, then I can say that 1 is a factor of 4, 1 is the factor of 18 also. So I can say that 1 is a common factor, right? 1 is a common. 2 is also common, right? Other than these two factors, no factor is common. We can just check. 4 is a factor of 4, but 4 doesn't appear as a factor of 18. Similarly, 3, 6, 9, and 18 are not factor of 4. So common factors, if I say for these two numbers, will be 1 and 2. So 1 and 2 are called common factors, right? I hope you have understood it. So let's take another example and let us take some numbers, say 20 and 36, right? Pause the video and try to find the common factors of both these numbers. Okay, I hope you have done it, right? Now let us check whether you have got the right common factors for both these numbers or not. The very first thing is that we have to write all the factors of 20. So what I'll be doing is that I'll be starting with 1. 1 divides 20. 2 is a factor. 3 is not a factor because 20 doesn't appear in a table of 3. 4 would be the factor, right? Because 4 into 5 is 20. Then 5 is a factor, correct? 6 is not a factor. 7 is not a factor. 8 is not a factor. 9 is not a factor, but 10 is a factor, right? Other than this, you can check that 11, 12, 13, etc. will not be factor. Immediately, it will be 20. So how many factors are there? There are 6 factors. Similarly, for 36, 1 is a factor, 2 is a factor, 3 is a factor, 4, 2 is a factor, right? But 5 is not a factor. 36 is not divisible by 5. Then after 4, 6 is a factor. Then the next number is, after 6, it will be 9, right? Then next would be 12. Then I think 18. And immediately the next number would be 36. Let us count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So there are 9 factors of 36. Now what are common factors? Let us check. 1 is a common factor. 2 is a common factor. 3 is not appearing in both, but 4 is a common factor. Right? 5 is not appearing. 6 is not appearing. 10 is not appearing, right? And 20 is also not appearing. Similarly, 12, 18, and 36 is not appearing in both. So we can say that these are the common factors of 20 and 36, right? Now, in the last class, we wrote all the factors of any particular number, right? Now, I want to share a small trick if you want to find all the factors of 36, apart from the prime factorization way. One way is that initial few factors you can judge very easily. For example, for 36, I wrote all these factors. How do you write all those factors? If you want to write them quickly, then what you can do is that this is trick, right? This is a small trick which you have to use. You start with 1. What should be multiplied with 1 so that you get 36? Just do this thing. So 1 should be multiplied with 36. So you'll be getting 36, right? Next, after 1, go for 2. Is 36 comes in a table of 2? Yes. How many times? 18 times, right? Similarly, the next number is 3. 3 into something should be 36. So meaning that 3 into 12 is 36. Then 4 into 9 is 36, right? 5, it will not be divisible. 6 into 6 is equal to 36. Once these numbers are either very close or equal, then you have to stop, right? Because the next number will not, if you want to go, go ahead, you'll find that it will be 7, but 7 is not divisible. 8 will not be divisible. Again, you'll be getting 9, but 9 has already been used, right? So once you exhaust this, that these numbers should be either close or they are equal, then you can see that you have written, you have wrote all the factors. How? You have written 1, you have written 2, you have written 3, you have written 4, you have written 6. You have written 1, 2, 3, 4, and 6. Next number would be 6, has appeared twice. Obviously, there is no need to write it again. You have written 9, you have written 12, you have written 18, you have written 36. You have written 9, you have written 12, you have written 18, and you have written 36. So the best way to write all the factors, if the number is small. Of course, if the number is higher, then definitely we use this particular logic only. But obviously, the time taken would be much higher. So this is all about common factors, right? Now, is it necessary that if I have two numbers, I'll be getting common factors more than once? Let's see that, right? For that, we have to take two such numbers. I will be taking both the numbers to be prime numbers. Let us see that how prime numbers behave for common factors. So let us start with the smaller prime number. Say 2, the next prime number is 3. Obviously, the number of factors for the prime number 2 is 1 and 2 only, because that's the definition of prime number. The number which has only two different factors, is prime number. Similarly, for 3, we'll be getting 1 and 3. So we can see that the common factor is only 1 for any two prime number. Is it true for any two pair of prime number? Yes. Why so? Because they are not divisible by any other number. For example, if I take two prime numbers, say 17 and 23, we know that 17, the factors are 1 and 17, and the other is 1 and 23. Again, 1 is the only factor if I take both these numbers to be prime number, right? And this will appear for any two prime numbers. You can check on your own. You can take any larger prime number also. You'll find that only 1 is the common factor, right? So this is the peculiar behavior of any two prime number, that if you want to find the common factors, you'll be getting only 1, right? But is it so that only for prime number this happens? The answer is no. We can have two numbers which will exhibit the similar kind of relation what any two prime numbers are basically giving in terms of common factors. Let me take two numbers, which is 4 and 15. We all know that neither 4 is prime number nor 15 is a prime number. And if I want to write all the factors of 4, it will be 1, 2, and 4. Writing all the factors of 15, very small numbers, we can say start with 1. 2 obviously will not be a factor of 15 because it's an odd. 3 would be the factor, 5 would be the factor, and the next factor would be 15 itself. Right? Now you will find that apart from 1, there is nothing common between 4 and 15, although neither 4 nor 15 is prime number. So it's a peculiar behavior. In spite of not being prime number, a similar kind of relations we are getting. So what should we call these numbers? So we'll be calling both 4 and 15 as a pair. We call them, they are co-prime. So co-prime is a word for which I did all these things to explain you that if I say that the two numbers are co-prime, that means they will have only 1 as the common factor. Both these numbers may not be prime. One of the number can be prime, the other is not prime. Both can be prime, both cannot be prime, or they both can be composite also. It doesn't matter. If they exhibit this relation that after finding common factor and you get only 1 as the common factor, then we will be calling both these number to be co-prime. So even 2 and 3 both being prime also, they are exhibiting a relation which will be called as they are co-prime. So please remember that prime number is a definition. Co-prime number is a relation. So for a definition, you need a single number. I'll ask a question. Is 17 a prime number? Your answer would be yes or no, depending upon whether you know whether 17 is a prime number or not, right? So 17 is a prime number. It's by definition. But co-prime is a relation. I can't say that. I can't ask this question. Is 17 a co-prime number? It's a weird question. We have to have another number for which after taking both together, we can make any assessment about being co-prime or not. Right? For example, if I take the number 4 and 15, which I took, I can say that these two are co-prime to each other. They are co-prime to each other. So obviously there is a relation. So again, prime number is a definition. Co-prime number is a relation. So relation will only be established when there are at least two things. That's why we need two numbers to assess whether they are co-prime or not. I hope you have understood this logic, that what are co-prime numbers, what is co-prime, what are co-prime numbers, and what is prime numbers, and how these relations are interlinked, right? The common factor has to be only one. Okay. Now let's move to the next. Let's take another example, which is say 24 and 36. I'm taking two these numbers. Obviously, they are not co-prime. We can see that apart from 1, 2, and some other numbers probably are factors of 24 and 36. So they are not co-prime. Just by apparently looking at these numbers, we can say both are even numbers, right? But I want to find they might be having some common factors. I'm more interested, what is the largest or highest common factor? I'm more interested in the largest or the highest common factor. So obviously the process will be same. I need to find all the common factors, and among them I'll be finding which one is the highest, right? So 24, if I want to find the common factors, then this will be 1, 2. If I want to find all the factors, 1, 2, it is 3. Then the next number will be 4. 5 is not divisible. 6. 6 into 4 is 24, no, right? So after 6, it will be 12 and then 24. Correct? You can take this logic also, 24, 1 into 24, then 2 into 12, 3 into 8. 3 into 8 is also right. So obviously I missed this. So यहाँ पे 8 भी आएगा. Then 4 into 6. And the next one is, I think we are done, right? So 1, 2, 3, 4, 1, 2, 3, 4, 6, 8, 12, and 24. These are factors of 24. Similarly for 36, we know that this is 1, 2, 3. We have already done it. So I'm just writing it here. 4, then it would be 6, then it would be 9, then 18, then 36. Let me count. 1, 2, 3, 4, 5, 6, 7, and 8. Yes, there are 8 factors of this. But if you look at closely, then we can say that all these factors, initial factors, are common, right? But which is the highest among them? The highest among them is 6. So if I ask you common factors, then it would be 1, 2, 3, 4, and 6. But if I ask you the highest common factor, so I'm taking the abbreviation. So now you must have seen this abbreviation, HCF. We call it HCF. So what is HCF? It is highest common factor. So which is the highest common factor in this case? 6. So 6 becomes the HCF of these two numbers, right? So if the question says that find HCF of these two numbers, then this is the answer. And what is this? Highest common factor, right? There is another name for highest common factor. At times it appears in the books, right? And that is GCD. We say that greatest common divisor, right? We know that divisor and factor are interlinked. Greatest and highest are one of the same thing, I think, right? We'll not get into the grammar of it, but they are more or less same thing. And common is common among both. So whether we say HCF or we say GCD, both have the same meaning. Normally we use HCF, but in some book, they are also written as GCD, right? So don't get confused when you come across this term GCD. So I hope you have understood what is HCF. And let us take some examples of finding the HCFs, right? So we'll be finding the HCF of some numbers. In fact, let me give you some time. You pause the video, find the HCF of those numbers, and then I'll solve it and compare it. You can compare your answers with that, right? So let me start with simple example. Find HCF or GCD of, right? The first is 8 and 12. You can quickly start, right? The next I'm taking is 15, 25, and 30. The third is 20, 28, and 36, right? Please pause the video, take some time. You may take some, say, 4 or 5 minutes also. Don't worry about the time taken, but you should be getting the right answers, right? Please pause the video, and then after you have got the right answer, you can play it again. Okay, I hope you have done it, right? Now let's check. 8 and 12. So what is the factors of 8? Factors of 8 is what? 1, 2, 4, and 8. And what is the factor of 12? This would be 1, 2, 4, 6, sorry, this will be 3 also. 1, 2, 3, 4, 6, and 12. Right? So what are the highest common factor? You can see that the highest common factor is 4. So 4 becomes the answer for 8 and 12. Similarly, for 15, 25 and 30, since there are 3 numbers, so the highest common factor should appear in all 3. This is one way of finding the factors and finding the common factor. It should work for the smaller number. But what about for the bigger number? So for bigger number, what we do is that we observe that 4 is the common factor. If I want to factorize the prime factorize this number 4, it appears 2 into 2. This is the prime factorization of 4. So can I say, if I can prime factorize the common factor, this should also appear in the prime factorization of these respective numbers. This is one way of finding the LCM, right? But this is not the right way, right? In the sense, I mean to say, this is not the quick way of doing so. The quick way is finding the prime factorization way, right? So let us see that what is the, how do we find the HCF or LCM, HCF only, right? If we are using prime factorization way. So what I'll be doing is that 8 is written as 2 into 2 into 2. Fine. This is the prime factorization of this. 12, 2 into 2 into 3. I hope you remember. This is the way I do, right? Long division method. 2, 4 times. 2 again 2 times. 2 again 1 times. So the product of all these 3 is equal to 8. Similarly, for 12, we can see that 2 6 times, then 2 3 times, then 3 1 times. Again, so product of all these 3 will be equal to 12. Now, what we can do is that we can select the factors which are common. 1, 2 is common, the another 2 is common. Here, this 2 don't appear in, the third 2 is not appearing in 12 and 3 is not appearing in 8. So there is no common. So what we can see is that the HCF would be 2 into 2, which will be equal to, right? So here, this is an interesting way because this is quick and the chances of missing out any factors for the given numbers is also ruled out. That's the reason we use this prime factorization way of finding HCF. Right, guys? Fine. So I hope you must have gone through this way, but this is also one way of finding the HCF. By doing so, you are actually solving it in a very rudimentary way, and that is also required, right? Then only you can appreciate the best way of finding it. Okay, so the next number is 15, 20, and 30. So let me just remove everything. 15, 25, and 30. So 15, the prime factorization is what? 3 into 5, right? 25, the prime factorization is not divisible by 2, neither divisible by 3. So obviously the next number will be 5 into 5, right? I hope you can do it by long division method, right? So I'm not doing it again and again. Next is 30. It will be 2 into 3 into 5. Now you can see that 3 is appearing here and here, but it is not appearing in the second one. So it's not a common one, right? Although the best approach is that you start with 2. 2 is appearing here, but it is not appearing in other 2. So obviously this is ignored. 3 is appearing here, 3 is appearing here, but 3 is not appearing in the third one. We need common. So we need that prime number should appear in all 3. So 3 again is ruled out. 5 is appearing here, 5 is appearing here, 5 is also appearing here. So we can say that 5 becomes the common factor. Apart from that, the next 5, there is one more 5 in 25, but there is only one 5 in the rest of the 2 numbers. So 5 will again not be common one. Only one 5 will be taken, right? Which one? This, and this. This would be ignored. So 5 becomes the HCF, right? What was the next number? The next number was, I think, 20, 28, and 36. Again, the prime factorization of this is this much. I hope you all have become expert in prime factorizing the numbers, right? This is 2 into 2 into 7. This would be 2 into 2 into 3 into 3. Can I say this is common? This 2 is common. Other than that, you can just observe there is nothing common. Correct? So what would be the HCF, guys? The product of the common prime numbers or the common prime factors. This 2 and this 2. There are 2 groups of 2. So from each group, we'll be taking 2. So overall, you'll find that 4 becomes the highest common factor. And you can cross check by taking all the factors of all the 3 numbers also. Right? So I hope you have understood what are factors. We'll move to next section, which will be about finding LCM.